So this example comes from the basic concepts module. At this point, some of the quantities employed might look abstract or completely out of the blue. Keep in mind what is important for you now is to understand the methodology of solving problems rather than exactly what are the quantities in the questions about. So what is the first step at every case, at every problem, is to read the problem itself. Then we need to have a drawing and draw, pick, select our input. Write down the input again with the correct units and the necessary equations. Now, I read the problem and I start doing the drawing. So we know that we have two plates, the top and the bottom one. Both of them have the same area equal to A, and they're separated by a fluid of known thickness. Let me use symbol delta. As I said, a force is applied, and because of this, the top plate is moving with a known velocity. So all my input is A equal to 30 square meter, the velocity magnitude, okay, is equal to 0.3 meters per second, force 45 Newton, and it's good also to cross out whatever you use. So I use this, this and this, but I forgot to use delta. Unfortunately, many times some input will not come as a value, but anyway, this is a good method not to forget any units, and of course to convert them right away to the appropriate system. And a very important also aspect, every drawing needs a coordinate system, X and Y. Now, as a little bit more information, what exactly is happening in the fluid between the two plates? Well, we can guess that the top layer of the fluid is moving with a velocity. It's probably exactly similar equal to the velocity of the plate. Same wise, the bottom layer of the fluid is not moving at all because the plate that is in adjacent is fixed. What happens in between? We have layers moving with lower velocity as we move downwards. From the Newton's law for viscosity, we know that the shear stress equals the viscosity times the velocity difference over the depth, the thickness. Now, we know the velocity, we know the thickness, but we don't know the shear stress. Again, from the same law, we know that shear stress equals force over the area where the force is applied. If we combine these two, we get that the velocity over the thickness times the viscosity equals force over area. We are looking for the viscosity, so this one is equal to force times thickness velocity gradient difference times area. If we substitute the values here, we get that viscosity equals 45 Newton times what is the thickness, 0.8 10 to the power minus 3 meters over 0.3 meters per second times 30 square meter. Cancel out the units that can be cancelled. In this case is the meters and the meters, and let me fetch my calculator. 45 times 0.8 to the powers of minus 3 over 0.3 over 30 equals 4 times 10 to the power of minus 3 Newton per square meter. So here's the whole